Howdy folks, some more on quantum mechanical issues. Well, I'll take a... Yes, here I am. Okay, sorry. I'd like to discuss the previous film about quantum mechanics and macroscopic issues. But before I do that, I also added in the text below. I added some information which I discussed, and I also here discussed that information. First, I'd like to make some definitions, some definitions. Well, first some terms which I came up with. In the first place, you have something which is called an individual or an unbound wave function, an IWF or an UWF. An unbound or individual wave function, that's actually the same. But also you got a bound wave function. An individual or an unbound wave function is a wave function that is loosely appearing in space-time actually. It's not confined to a rigid body or a macroscopic object. That's the next definition, a macroscopic object. A macroscopic object, it consists of bound wave functions. I mean, it contains atoms, it contains electrons, and all that kind of stuff. So these are bound wave functions in a macroscopic object. A macroscopic object, as we know, consists of atoms and electrons and so. And these are bound by energy wells due to electromagnetic interaction. But a free particle like a gas atom or a light photon, an individual photon that is floating around here, is an unbound. Is not bound. It's not bound by an energy well of some kind. Okay, then you got the locality and non-locality. Locality is that the chance, where the highest chance to find a particle, to meet it over there, and the non-local areas of a particle is there where it's lesser, the chance is lesser to be found of the particle, but it's still there. I mean, there is still a chance, but in the center, it's a local thing where you can say, okay, the most probable. The highest probability to find particle is in the local area, and it's far more lesser chance to find it in a non-local area. But there is a particle spread out in space-time. That's apparently how nature functions. And okay, but once it gets confined in an energy well, that local part is shrinking down to that area of the energy well, and the non-local areas are spread out outside of the energy well due to tunneling. Okay, that's what I did over here. What you can see here is an energy well here. But that's part. We have to remember that every macroscopic object consists of particles that are in a bound state. So they are in an energy well. They're vibrating, resonating actually in an energy well, and so they are more confined and more localized. But that doesn't mean that they don't have non-local properties as well. We know due to tunneling that a particle can also have a very slightly chance to be outside of the energy well. That's where radioactivity is based upon. And so we have to remember that macroscopic objects like the detection screen consists of all bound wave functions that are the highest probability to be found inside of that energy well, like an atom, etc., a molecule, etc. Okay. What happens is that a macroscopic object is actually sending out particles, whether it's an electron, whether it's a photon or a neutron or whatever kind of stuff, doesn't matter, or even a molecule. I mean, you can also have a molecule as a particle which behaves the same way. But what happens is that, for example, a laser. I took a laser as an example, as a macroscopic object. It's sending out photons, but these photons have a local part, like this, and a non-local part, non-local parts, just like a ripple on the water surface. You see it spreading out more and more, but also that because of it has a local part and a non-local parts, then entanglement is a logical consequence of making individual particles unbound wave functions. So there is an entanglement between the source of the particle and the particle itself. That's you cannot avoid it. And next to that, if it moves on and comes in to the two slits, it splits like a normal wave it is doing. But also the two slit thing is a molecular, a macroscopic object. Then it splits into two, or the wave is splitting into two. And the thing is that since the wave particle has a local and a non-local part, the non-local part is the first one to encounter the non-local part of the bound wave function of the particles in the screen, in the detection screen. So actually these non-local parts of, in this case, the light wave function are interacting, and they are actually interacting in such a way that the light particle may be deflected to that point, due to the interaction of the non-local parts first. That's the first part of the wave function that interacts. And so it may be drawn by the non-local function to resonate better over here with an electron over here than an electron over here. Yeah. So the non-local areas are interacting first and causing it to deflect to other sides. And so non-locality plays a very important role in where the particle on the screen is ending up. I mean, how should a wave function determine where to go? I mean, what you see is, of course, this kind of pattern. This kind of pattern. But how does a wave particle know how to go over here all the way? That can only be so if the non-local areas of the wave functions are interacting and it's drawing the particle over here. So because of the resonance over here with this, the non-local part of the electrons in the screen are resonating better at that moment with the wave function, the non-local part of the wave function over here, and the next maybe here. So it is drawn over there, etc. And then it ends up over here, that particle. So it gets confined. It gets bound again. The unbound wave function gets bound again, and then it appears as a dot on the screen, and it is confined so that it's a bound wave function again, and that appears as a dot on the screen. Well, at this moment I don't have another explanation than this. That the locality and the non-locality play a very big part in how particles interact with each other, and that the non-local parts of a wave function are very important as well in the long range interactions of whatever kind of wave function particle. And that the non-local parts have an influence on how things operate. Well, that's what I want to share for a moment. I hope the picture you get is getting more clearer and clearer, because yeah, it's tough material. I don't have the math for this, but I can only show it to you in a drawing, and I don't have the mathematical things that I leave to other people. But this is in general the hypothesis I like to postulate, and yeah, I hope it resonates with you all. Okay, hasta la vista. See you next time. Thanks for watching.